Hi everybody, we're going to take a quick look at factorising and formalize some concepts that we've already been using informally. So factorising is a useful skill used to assist when simplifying expressions. It's the inverse of expanding. So if we had the expression a times b plus c, that would expand to a times b is ab and a times c is ac using distributive law. Now if we're going to do that backwards, we'd have to look at AB and AC and consider what's common between them. In this case it's A, so we're going to put that outside the bracket. And then we'll think, well, what do I multiply A by, this A here, to make AB? We'll have to multiply it by B, so I'm going to put that in the bracket. What do I have to multiply A by to make AC? We'll have to multiply it by C and put that in the bracket. Here's another case, A times 3 plus 4B. If we expand that, that'd be A times 3, which is 3A, and A times 4B, which is 4AB. If we're going to do this backwards, factorize this expression here, I've written it there, I think, well, what's common, oops, I think I missed something out there. What's common between these two terms? Well, it's the A, so I'll put that outside the bracket. What do I multiply A by to get 3A? Well, I multiply it by 3. What do I multiply A by to get 4AB? I multiply it by 4B. That's what's missing. All right, as you can see, factorizing, some students really get themselves in a knot over this, but it's not actually that difficult. So what do you have to do this easily? Well, to factorize terms, identify, do the coefficients have a highest common factor other than 1? And do they have any common variables? If we can identify either of these things, we call these the common factors and place them outside the bracket. And then we consider, what do we have to multiply it by to get back to the original terms? And in this case, it was 3 and 4b. We're going to put those inside the bracket and be careful to preserve the operator in the middle. And sometimes before the terms, the first term. So here we go. Here's 9x plus 6. 3 will divide into 9 and 6, so we're going to place that out the front. The second term hasn't got an x, so that won't be a common factor. Now what do I have to multiply 3 by to make 9x? Well, it'll be 3x. 3 times 3 is 9, times x is 9x, and put it there. What do I have to multiply 3 by to make 6? That'll be 2, not 3. So we'll fix that up. Three times 2 makes 6. And we now have our factored expression. Let's look at the next one. 10 plus 15a. Well, the highest common factor in this case is going to be 5. Put that there, put it outside the bracket. 5 times 2 gives me 10, so the first multiple is going to be 2. 5 times 3a will give me 15a, that's going to be the second multiple. 4m and 6n, well, that's going to be 2. The highest common factor of 4 and 6 is 2. 2 times 2m gives me 4m. 2 times negative 3n gives me negative 6n. These are the two multiples. That times that gives me this. That times that gives me this. All right, next one. This one's a bit more difficult because it goes back to that property where if we have x times x, it's x squared. So this has x times x and this has x, so it has a common factor of x. Put that outside. X times x gives me x squared. X times 7 gives me 7x. Brilliant. Common factor of 2a squared and negative 3a would be a, so place that outside the bracket. A times 2a gives me 2a squared. A times negative 3 gives me negative 3a. Perfect. Highest common factor of 12y and 6y squared. Well, if we look at the common factors first, it'll be 6. 6 goes into 6 and 6 goes into 12. Highest common factor of y and y squared is y. So we'll put 6y outside the bracket. 6y times 2 will give me 12y. 6y times negative 3y will give me negative 18y squared. Well, that's not right. So we better fix that. That's why it's always worth checking your answer. 6y times negative y will give me negative 6y squared. Oops, still can't get it right. It's not approximately. It's negative. Try again. Pen can be a bit fiddly to use sometimes. Yuck. That'll do. Okay, next one. Highest common factor of AB and negative bx would be b. Try multiply b by a to get ab, and b by negative x to get negative bx. So the multiples are a and negative x, the factor is b. Highest common factor in this case would be s. Place that outside the bracket. S times t gives me st, and s times negative 1 gives me negative s. Perfect. Highest common factor of 4ab and 10b squared. Well, the highest common factor of 4 and 10 is 2. Highest common factor of AB and BC is just b, so we'll put 2b out the front. 2b times 2a gives me 4ab. 2b times 5c gives me 10bc. Perfect. Now, we could do this in a couple of ways by taking out of a negative factor or a positive factor. In this case, I've chosen to take out a positive factor. Highest common factor of negative 4 and 6 is 2. We could just as easily have done negative 2. 2 times negative 2m gives me negative 4m. 2 times 3n gives me 6n. Now, the convention would be normally to reverse these, because the commutative property says we can change the order of terms when we're adding. So we'd write 3n take 2m. I haven't done that just for simplicity's sake of focusing on factorising and not on simplifying terms. Negative x squared take 3x. Highest common factor is negative x. They both are negative. They both have an x. Negative x times x is negative x squared. Negative x times 3 is negative 3x. Highest common factor of negative 15a and 5ab. Highest common factor of 5 and 15 is 5. Highest common factor of a and ab is just a, so factor will be 5a. 5a times negative 3a gives me negative 15a. 5a times b is 5ab. Perfect. Now, why did we do all this? Well, factorising can be helpful when simplifying fractions. If we start with this expression here, if we then factorise it, we'll end up with 5x plus 2, the numerator are factorised, and that allows us to cancel the 5's. So if we think about what is actually going on here, once we've got this expression, we can break that up into 5 on 5 times x plus 2 on 1. The 5 on 5 cancels out. 1 times anything is itself. We are left with x plus 2. Same with this case. We factorise out the 2. From here, we get this expression here. We think about it in this sense, we're going to end up with x take 5 on x take 5. They will cancel out because that's just 1. 2 on 1 is just 2. 2 times 1 is 2. That's this answer here. 3a plus 9 on 6a plus 18. If we factorise out the 3 in the numerator, we get this expression. We factorise out 6 in the denominator, we get this expression. We then break up the fraction to be 3 on 6 times a plus 3 on a plus 3. The a plus 3's cancel out. 3 on 6 is just a half. But we have to be careful because it's really easy to make mistakes here if your thinking isn't correct with regards to how you're simplifying this part here. Cancelling can be very deceptive if you don't have a good understanding of it. Okay, so there's a bit of information on factorising, and I hope that's helpful. Thanks everyone, I'll see you in the next one.